Hello students, how are you? I hope you all are doing fine, okay? I hope you all are staying in home using sanitizer, okay? Wearing mask if you are going outside, okay? So this is going to be our next part, okay? Or you can say the part 3 of the lesson, light, reflection and refraction, okay? So today we will start from the part where we have actually ended in the last part, okay? Or in the last video, okay? So our today's topic will be representation of the images using spherical mirrors, okay? This is going to be our next part. Our today's first topic is going to be representation of the images formed by the spherical mirrors. Okay, till now we have actually discussed what is actually spherical mirrors are, what kind of spherical mirrors are there. There is two types of spherical mirrors, concave mirror and convex mirror. Then we have discussed real and virtual images, right? We actually got concept of all those things, right? Now we have to use all those concepts here. Okay, we are going to get real images, virtual images when we will actually discuss the formation of the images, right? Today we will actually first discuss the representation of the images formed by the spherical mirrors using what? Do you know what we will use? We will use rays. Okay, that incoming rays, reflected rays, those are rays, na? That's why those are known as what? Ray diagram. Okay, ray diagrams. Okay, in exam maybe there is a question that draw the ray diagram of something. Okay, if the object is at here or object is there. Okay, in actually life lesson, when we will discuss the object, we are always going to mention the object as a line like that. Okay, this is going to be the head of the object, this is the base of the object. See, when we are discussing an object, it is going to have lots of points right here like this, lots of points are there. Okay, and from the each point actually lots of rays will come and will incident on the reflecting surface. Okay, but the thing is, for our convenience, okay, only for our convenience, we will only consider two incoming rays from the object. That means we can say that we will consider only two rays that will reflect on the reflecting surface. Okay, once I will draw, you will actually understand. Okay, clear now? Now first I will actually discuss with you some of the rays. Okay, we'll consider some of the rays, when it will pass through focus, what will happen when it will actually pass through center, what will happen when it will incident parallelly on the screen, what will happen. There are some conditions. After that, okay, we are going to combine those rays and then we are going to get some images. Okay, our first condition is going to be when an incident ray incident parallelly, okay, to the principal axis. Okay, see, this is the main heading. Now we are going to consider two reflecting mirrors. What are those? Concave and convex mirror. First I will draw one. See, I will draw a bit bigger size. Okay, it will be then actually visible for you. This is the concave mirror. First I will draw one, the principal axis. This is the pole, this is the focus, twice the focal length is the center. Okay, first condition of what? When an incident ray incident parallel to the principal axis, that means what? The incident ray will be parallel to the principal axis. This is the incident ray. Once it get incident, what will happen? It will pass through the focus. Okay, now we will consider one more mirror. There is what mirror? Convex mirror, right? Convex mirror. What will we do? We will actually increase the principal axis like that. There will be one focus, this is the center. Same thing will happen. What will happen? When an incident ray incident parallel to the principal axis, that means what? We will consider one more ray which will be parallel to the principal axis. This is the principal axis. Sorry, this is not a proper line. Okay, this is the incident ray actually parallel to the principal axis. After getting reflected, what will happen? It will reflected like that. But since it is a nature of the convex mirror that it always diverges, right? Or it tends to diverge from a certain point in case by convex mirror. So we have to actually draw a dotted line till or towards focus. Okay, now just look closely in the figure. What is actually happening? In case of the concave mirror, it has a property of the converging property, right? So what will happen after the ray getting incident on the certain point, it will be moved towards the or moved through the focus. That means it is just converging towards the focus. But in case of a convex mirror, what is actually happening? After getting reflected, that ray is appeared to be diverse from focus. Okay, look closely. It is actually looking like that ray is coming from what, or coming out of what? Focus. That is known as the appeared to be diverse from focus. Okay, this is the first condition. Okay, if you want, you can actually draw it and just pause the video and draw it properly. Okay, if you want, actually you can actually find from your book. Okay, one more thing actually I have given to draw the normal, and normal is always from the center. That normally looks like that. This is going to be the incident angle and this is going to be the reflected angle. In here, we are going to be on normal. Okay, since this is the incident ray, this is going to be the incident angle. Since this is the reflected, this is going to be the reflected angle. Okay, in my case, these two angles are not actually similar. Once you draw in book, use properly, then it will be your similar. Okay, this is our first case. Now our next topic is going to be when the incident ray, okay, when the incident ray move through the focus, focus. Okay, now we are going to observe what will happen when the incident ray move through the focus. First, I will again draw concave mirror. This is the pole, this is the focus, this is the center. This whole ray is known as what? And the whole axis is known as what? Principal axis. Now the heading is when the incident ray move through the focus. That means what? We will draw one incident ray which will move towards the focus. This is the incident ray. What is going to happen when it get incident on the reflecting surface? The reflected ray will move parallelly to the principal axis. Understand? Simple, quite simple. You don't have to worry about anything. Quite simple. Okay. Now this is the convex mirror, right? Convex mirror. Okay. I will draw the normal like that. This is the normal. This is the incident angle. This is the reflected angle. Now what will happen? We have to draw the incident ray move through the focus, but in case of the convex mirror, what will happen? The incident ray, okay, not going to move directly through the focus, okay, but it will appear that actually moving towards the focus. That's why we have to say that in case of the convex mirror, the incident ray is directed towards the focus. Okay, somehow it will look like this. Okay, it will look like this. Okay, it is the incident ray. After getting incident, what will happen? That it will actually move parallelly to the principal axis. Oh, we have not given the focus. This is the center. Okay, this is the incident ray. This is the reflected ray. Once we give the dotted line to focus, now look closely. What is happening? It is actually looking like that this incident ray actually moving or actually directed towards the focus. Simple. So that's what it actually means. Now we have to give the normal. This is the incident ray, incident angle. This is the reflected angle. Okay. In case of the convex mirror, don't get confused. Okay. I have told in the last video that in case of the convex mirror, most of the things is going to happen in the virtual world. Okay. This world is known as what? Those dotted lines are in the world. Which world? Virtual world. In case of the concave mirror, the main things are happening in what? Actually world, real world. Okay. That's why we have to give the dotted lines, and don't get confused with dotted lines. Dotted lines are actually imaginary part. Okay. If we increase the dotted line till focus, what it actually looking like? That incident ray is looking like that this is directed towards the focus and it will move through the focus. Simple. Now we will actually move towards. Okay. If you want to draw it, just pause the video again. Just completely draw it. Now we'll move towards the third part. Okay, third thing. Here we'll consider what will happen if the incident ray move directly through the center. Okay, when the incident ray move, or just you can say right, move through the center of what? Curvature. Oh, by the way, one thing. See, lots of students are actually watching my video, okay, but less of the students are subscribing. Simple सी तो बात है ना भाई, लाल बटन को ग्रे कर दो, हो गया subscribe, and press the notification button. Okay, then what will happen? You are going to get my notifications. Okay, my uploading of videos, you are going to get notifications. Okay, और क्या होता है? सिंपल सी बात है, सब्सक्राइब करने से मेरे को encouragement मिलेगा ना, so कर दो. Simple thing. Okay, okay. Now this is our third topic. What will happen? I will draw first the what? Concave mirror. Then first what will happen? I will draw the focus, the center. This is the pole. What I have said there, what will happen when the incident ray move through the center of curvature? See, if I draw a line like that, okay, I will erase this part. Okay, if you get any doubt on my videos, just ask me in the comment sections. Okay, okay, by the way, today you are going to have some competition in this video. Okay, so just wait till the end of the video. Okay, this is the incident ray, but what will happen that in this case, that incident ray and the reflected ray will be on the same line. Okay, we will actually discuss why it is actually happening. That means we are going to have the reflected ray in the same line of the incident ray. That means the reflected ray will be like this. Understood? Now we will see what will happen in case of the convex mirror. Simple thing is going to happen. This is the pole, this is the focus, sorry, this is the center. Okay, we have to draw a line which will actually directed towards center. When like the last case, what will happen? That reflected ray or the incident ray actually directed towards what? Focus. Now you have to draw a line which will actually look like that. That ray will move towards the or directed towards the center. So what will you do? We will draw a line like that. This is the incident ray. Now we will actually increase the ray by dotted lines like that. That means what it is looking like, that ray is actually directed towards the center. Okay, similar case will happen if this is the incident line, the reflected ray will be in the same line. Now why it is actually happening? What is the reason? See, there may be one mark question, that when the incident ray move towards the or move through the center, why the reflected ray in the same line of that of the incident line? What can be the reason? Because that incident ray getting incident normally in the reflecting surface. Okay, consider this as a parallel mirror. Okay, consider this as a parallel mirror. What is going to happen if this is an object incident normally in the reflecting surface? What is going to happen? That incident angle and the reflected angle are going to have zero angle with the normal. That means what? That reflected ray will be in the same direction, or not the same direction, in the same line in the opposite direction. Okay, always incident ray and reflected ray are going to have some kind of opposite directions. Okay, if it is coming in this direction, it is going in this direction. That's why it is known as the opposite direction, right? Why actually it is happening? Because this angle is the 90-degree angle. That means this angle is going to be also 90 degree. This angle is going to be also 90 degree. This is the main reason. Okay, that's why it is actually happening. There may be one on my question. Always remember that. Okay, this was the third case. Now the last case is what will happen when the incident ray incident obliquely in the reflecting surface at a certain point. Okay, we will actually look for that. First, I will erase this part. Okay, our next topic is going to be when the incident obliquely, okay, obliquely at a certain point. Okay, now first we have to understood what does that word means. Obliquely means making certain angle with the principal axis, or you can say with the normal. Okay, it will make some angle with the principal axis. That incident ray will make some angle with the, if this is the principal axis, it will make some angle. Okay, this is going to be angle. So that is actually meant by the obliquely. Okay, now first we will consider what mirror? Concave mirror. This is going to be the concave mirror. Okay, this is the principal axis, this is the pole, this is the focus, this is the center. What I have also told you, that what is going to happen when a incident ray incident obliquely at a certain point. Obliquely means at the pole, we can say it will make an angle I. If this is the normal, simple law of reflection, if this is the normal, this is the incident angle, what will going to happen? That reflected ray, or sorry, the reflected ray will make the same amount of angle or equal angle with the principal axis. Okay, this is the R. Okay, so this is the thing that happens in case of a concave mirror. Now simple case is going to happen in case of a convex mirror. You can increase like that. This is the pole, this is the focus, this is the center. Okay, it will incident obliquely like this, same angle I. Again it will move like that, same angle R. Simple concept, nothing to actually explain. Simple concept of actually light getting incident at a certain point, or you can say that the pole after getting incident, it will be reflected with the same amount of reflected angle with that incident angle. Simple concept, right? This is the main actually 4 points of the topic, the representation of the images formed by the spherical mirrors using ray diagrams. Okay, now we are going to see how the image actually get constructed using concave mirror and convex mirror. First, today only we will discuss the concave mirror part. Okay, see what is going to happen when we will actually combine among those 4 cases that we have actually discussed. When we are going to actually coincide 2 cases, okay, then we are going to get one image. Simply, if I say simply, we are going to get, or we are going to need actually 2 reflecting rays, okay, to construct one image. So tell me one thing, if this is the image, sorry, this is the object, if this is a plane mirror, if one reflecting ray going to give us the image? No, because it is not going to meet at anywhere. If there is 2 reflecting rays, what will happen? At a certain point, it will actually give us the image. Simple case is going to happen here too. We are going to get 2 reflecting rays. At a point, they will meet and they will give us image. Simple thing, right? Our next topic is image formation by the concave mirror, right? Okay, before starting the image formation of the concave mirror, there is going to be one chart. Okay, now you are looking at the chart in your screen. Okay, there are going to be 6 positions in the principal axis where the object will be. Okay, depending on the position of the object, you are going to get the position of the image. Okay, and depending on the position of the object, we are going to get the different sizes of the images. Okay, but the nature will be same for the 5 conditions. Only in one condition the nature of the image will be different. Okay, now we will actually move towards the first one. Our first position is going to be at infinity. Okay, the first we will look what will happen in case of a concave mirror when we will place the object at infinity. Okay, first I will draw one concave mirror. Okay, I have drawn it in bigger size. This is not a proper line. This actually happens when you draw freely. Never draw freely in your exam. Okay, this is my strict order to you. Okay, this is the pole, this is the focus, this is the center. That means we have now one position that image object will be at infinity. It means what? We don't know where it will be. At a certain point at infinity, that means it will be at infinite distance where actually you can't observe. That's why we will consider the incoming ray like that. It means that ray is coming from some object which is at infinity. This is the one parallel ray. What is the property of the concave mirror? It will always converge to the what? Focus. Okay. Now one more ray. Because why one more ray? Because we are going to need two reflecting rays to construct an image. From one incident ray we are going to get only one reflected ray. Now we are going to need, for our need, that if you need one more reflecting ray, we are going to need one more incident ray. That's why we will draw one more incident ray. This is the incident ray. Again same thing will happen, same property. This is the reflected ray. Now look closely. This is the point, right? This is the point. This is the focus now. This is the point where actually the two reflecting rays are meeting, right? That means this point is going to give us the image. But the thing is, the size of the image will be what? Point size, because this is a point. Okay, so we can write from this figure that size of the image will be point sized. Okay, or you can say highly diminished. Highly diminished. Okay, now nature of the image, real and inverted. Real and inverted. Because why? This image is forming in the real world. Okay, and I told you the last part that if the image is real, it is going to be inverted. Okay, with real there is not going to be erect image, and with virtual image there is going to be inverted image. If there is real image, that is going to be the inverted image. And why the real and inverted image? Because the reflecting rays are meeting at the real world. That means in the left side of the concave mirror, where you can actually observe two rays are meeting. Okay, again position of the image. The position of image will be what? At focus, or you can say at principal focus. This is the thing. Okay, these are the main three things that we have to actually mention. When there is a question that draw the proper ray diagram when the object is at infinity. If you only draw this part, you do not write these things, you are not going to get the full marks. So you are going to maybe get 1 mark less. Okay, so you have to draw the proper figure and you have to write these three things. Okay, size of the image, okay, nature of the image, and the position of the image at focus. Simple thing. Okay, simple thing. Now we will move towards the next position. Okay, next position. Next position is going to be beyond C. Beyond C means what? Outside of C. Beyond C. To understand the position, first we will draw. Again, because we are discussing with the or dealing with the concave mirror, so we have to draw again and again concave mirror. Okay. First we have to draw the principal axis. Again, I told you now, whenever you have to draw the ray diagrams, first always draw the principal axis. Okay. This is the pole, this is the focus, this is the center. I will extend the ray a little bit. What is the position of the object at or beyond C? That means outside of C. Okay. From this thing, okay, before actually starting the topic of the representation of the images, I told you that we are going to only consider two convenient incident ray, from where we are going to get two reflecting rays, where they will meet, give us the image, right? So from this image, this is the A, this is the B. Okay, this is the one incident ray. From the property of the concave mirror, what is going to happen? This ray will move through the focus. Okay, and there will be one more ray which will pass through the center of curvature. Okay, what we have actually learned, when the ray moves through the center of curvature, it makes 90-degree angle with the reflecting surface. Okay, that's why you can say the reflecting ray will be in the same line but in the opposite direction. Okay, this is the thing that we have actually understood. Now the main thing is where the two reflecting rays meet. This is the position. Okay, and this position is going to give us the image of that object, and this object will, since this is a real and inverted, this is the inversion nature. That means if it is like that, it is now upside down. Okay, so this is going to be, if this is the image AB, this is going to be known as the B dash A dash. Okay, now from this figure what we can say, simple thing, size of the object, what will happen, it will be diminished, or simply you can write, this is the actually physical language. Okay, physics language. If you want to write in your own language, you can write that smaller than the object. Okay, but this is going to be the proper language. Okay, now the nature of the object, simple na, real and inverted, real and inverted, because it is happening in the real world. Now position, okay, position is going to be what, where it is actually forming, between C and F, right? Simply you should write between C and F. If you want to draw it, just pause the video, just simply draw it. Okay, now we will move towards the next one, next position. That point is going to be at C. Okay, when we will keep the object at C, what is actually going to happen? Okay, our next thing is going to be, sorry, not C, D position, actually is going to be C. Okay, C, at C. That means at we have to put the object at center of curvature of the principal axis. You should always use the proper compass to draw this actually spherical surface. Okay, since I can't use the actually compass here, that's why actually I am using freehand. Okay, first I will draw the pole. This is the focus, this is the center. Now we have to put the image at the center. This is the A, B. Again there is going to be two rays. One ray will, this one, from the property of the concave mirror, what is going to happen, it will move like that. Sorry, it should move little bit like that. Okay, again there will be one more ray. Okay, so I can move like that and it will pass through here. Now this is the point, this is the point where the two rays are actually meeting. So this point is going to give us the image. Then this image is known as B dash A dash. See, I told you when we are discussing about the representation of the images using ray diagrams, I told you we have to use two actually properties. Okay, then we are going to get the image. Now just remind or just rewind the video where we actually discuss the representation of the images. This upper part is, okay, this upper part is the first property and this is the second property. Okay, now from this figure what you actually can observe, from we can say that the size is going to be what, equal to object. Look closely in the figure, looking like similar. Okay, size is equal. Now we have to say nature. Nature is the same, real and inverted. Okay, now position is going to be what, at center of curvature. Okay, this is the main These three are the main things. Size is equal to the object. Okay, nature is real and inverted because it is actually occurring in the real world or the real part of the spherical mirror, and the position at the what center. Simple concept here. Just simply draw it. Just write these three things. Now we will move towards the fourth part. Now here we will do? We will put the object between C and F. That means center of curvature and the principal focus. We will observe what is going to happen. First I will erase this part. Our next thing is going to be between your actually question is coming for you, that you have to give me answer in the comment section. Okay, who is going to give me the correct answer? Okay, I am gonna tell his name in my next video. Okay, I'm gonna mention their name. Okay, proper name. When you just give me the answer, first tell me your name. So this is, my name is Dash. Okay, or my name is this. Then the answer is, for this reason this thing is happening. Okay, I will ask the question. Just properly listen, or I will write it down. Okay, you just have to watch the video and think deeply, then you will be able to give me the answer. Okay, I want answer from, I was just expecting that lots of students will give me the answer. Okay, just don't let me down. Try it. Okay, try it. Now what will happen between C and F? Between C and F means we will now put the object between C and F. Simply first I will draw one concave mirror. Okay, then I will give I'll draw the principal axis. This is the pole, this is the focus, this is the center. Okay, now what I have to draw? I have to draw one object A, B. Okay, first I will draw one incident ray. Okay, this is the ray, and this is one more ray. Okay, this ray incident making an angle 90 degree. Okay, so this ray will pass through the center. This is going to be the what? Reflected ray. Again, this ray incident obliquely in the reflecting surface. That means it makes certain angle, and with that angle it will reflected back through the focus. What is going to happen? That ray is going to meet at this point. Okay, this thing actually happens when you actually draw freely. Okay, this is the meeting point, right? So this point is going to be the image. If this is A and B, this is going to be what? B dash and A dash. Now look closely. From this figure, what we can actually predict? Actually we can say the size what? Enlarged. Okay, enlarged. That means we can say, okay, this is the focus. Enlarged. That means we can say the image size is little bit bigger than the object size. Look closely, right? This is the AB, this is the B dash A dash. Now nature is same, real and inverted. Real and inverted. Now what is the position? What is the position? Position is beyond C. Beyond C. Now one interesting is that when we put the image, not by the object beyond C, what happened? The image from between C and F. Okay, now this is the reverse thing. When we put the object between C and F, the image is forming beyond C. This is quite easy to actually remember. Okay, when the object will be beyond C, the image will form between C and F. When we will put the object between C and F, the image will form beyond C. Quite simple to understand, or quite simple to remember. This is the fourth one. Now we will move towards the fifth one. Here we are going to have a question actually this is going to be a competition type question. So, and you are not going to find it in your book, the answer. Okay, just you have to think. Okay, E, where what is going to happen? The object will be at F. That means focus. Look very carefully. Okay, and depending on this figure, you are going to get the question. sorry. This is the concave mirror, this is the principal axis, this is the pole, this is the focus, this is the center. Okay, I will consider this as the object. First I will, what is going to happen? Two ray will pass. This is one ray, okay, and this is another ray. Okay, similar thing will happen. See this angle, median angle, consider median angle 90 degree. It will directly pass through the center, and since this is the, again one more incident ray, the reflected ray will move through the focus. This is the reflected ray and this is the reflected ray. Now look closely here. This is the AB. Okay, yeah, this is the AB. This is the thing. Yes. Okay, everything is done. Okay, now look closely. What is happening? The two reflected ray now parallel. Okay, now we can say the two reflected ray are going to meet at infinity, right? That means we can say the position of the image is going to be at infinity, right? When we put the object at infinity, what happened? The image format in focus. Now the similar case and the reverse thing is happening. When we put the object at focus, the image is going to form at infinity. Now that means we can say position is at what? Position is going to be at infinity. At infinity, right? Nature is going to be the same. Nature is the same. What? Real and inverted. Okay, now my question is size. Regarding the size, I will tell you the size. That is not the question. What will be the size? Size is very enlarged. Now my question is, why the size is very enlarged? That means why the image size is going to be very much bigger than the object size. Now my question is, I will erase this part. If you want to write, just write it down. I will gonna actually erase completely. Okay, just pause the video and write it down. My question is going to be, why the image size is very enlarged. Why the image size is very enlarged when we put the object at f. That means my question is, why the image size is very enlarged when we put the object at focus. Okay, I need the answer. Okay, use some idea. Okay, look closely at the figure. This is the principal axis, this is the focus, this is the center. What can be the reason actually, or why the image size will be very much enlarged, okay, compared to the object size? Okay, give me the answer in the comment section with your name. Okay, I need the name. That's why then I'll be able to actually tell the name now when if you give me the correct answer, right? And I'm hoping that lots of students will be able to give me the answer. Okay, so give your best, right? Now we will move towards the last part of these positions. Okay, it will be between focus and center, pole. Our last one is going to be between focus and pole. Okay, now first I will draw the concave mirror. This is the principal axis, this is the pole, this is the F, this is the C. Okay, what I will do, I will draw one, object AB, give them AB. There from here there will be two incident ray. Okay, these two are the incident ray. since this has incident oblique, actually making angle 90 degree, it will pass through the focus. Okay, and since it has incident obliquely making an angle with the principal axis, going to what is going to happen, it will make angle like that. Now see what is actually happening. Tell me one thing, is these two reflecting rays, are these two reflecting rays going to meet at certain point? No, now obviously not, because they are actually expanding from each other. Now what is going to happen? I told you in the last part that in case of a concave mirror, there is only one case. Okay, there is only one case where we are going to get the image as partial and erect, and this is the main condition. Okay, when this kind of things happen, we have to increase the principal axis. Now we will draw dottedly. Okay, this is the point where the two reflecting rays meet, but partially. Okay, once we give the dotted lines, that becomes the partial world. That's why the image is going to be what? Partial. And erect. Erect means what? The direction of the image and object should be in the same direction. That means the object is at upright, okay, and it is in the upside actually also. So that means what? The image and object in the same direction. Okay, I can say in the, above the principal axis, right? That's why you can say the position at what? Behind the mirror. Behind the mirror. Okay, the image is forming behind the mirror, na? Okay, Nasser is going to be what? Partial and erect, because I actually explained you very well in the last video what does it actually mean partial and real. Okay, now Nasser gone position gone size. We can say very or not very actually enlarged. Enlarged. These are the main things, okay, of the concave mirror. Okay, and these 6 are the main position with which we are going to get the image, and depending on those actually position of the object, we are going to get the image positions. Okay, image size, right? See why this image is here, because we have put at in a certain way or in a certain point. That's why this image is forming like that. So we can say basically it is completely dependent on the position of the object, right? So these are the main 6 parts of the concave mirror. Okay, now we have actually discussed some representation of the images, right, and formation of the image by concave mirror. Okay, in the later part of the video, okay, or in the next video, we will actually discuss in case of convex mirror, because in one video if I discuss lots of things, the video is going to be much longer. Okay, and it becomes really boring, right, if I make a longer video. Okay, till now maybe the video has become almost 40+ minutes. Okay, so I will not actually make a longer video. Okay, in the next part we have lots of times to actually discuss. Don't worry about time. Okay, just go through the video properly. Okay, the last 2 videos, go through the again. If you have any doubt, just go through the video again and again. Okay, if you get any doubt, I am always there to ask me. Okay, you can just ask me in the comment section. I will always reply. Even I am just replying. Okay, so don't worry about that. Now your one job is going to be what? I need the answer of that question that I actually written down. Just pause in the video, read the question, give me the answer in the comment section. Quite simple. So till now we have covered these things. Okay, today I will end this video here. Okay, I will again meet you at the next part of the video, the part 4. It is again coming almost 1 or 2 days later. So wait for that video. Till now, just watch the video properly, attentively. Okay, since you're staying at home, use your headphone. Just watch the video in the table whenever you want. Just watch the video. Enjoy your life, na? Since you are not going to get this time. Okay, so use it properly. Okay, so this is the end of the video. Okay, I will again meet at the next part of the video. So till then, stay safe, keep spending time with your family, right? Sayonara.